are you guys? Welcome to our session, grade 10, Physical Sciences, exam preparation. Our focus today is chemistry. My name is Temba Nguve. Let's hope we have an interesting session today. We're just trying to look at the key aspect of the work, both in term 1 and term 2. That is going to help us in terms of adequately preparing ourselves for the June examination, which is a very, very critical part of our school calendar. So for that reason, we shall look at two segments, which are Section A and Section B, which is Section A, which is based on multiple choice, right? And then the second part is Section B, which is based on structured or long questions, right? Now, let's start with the multiple choice without any waste of time. 4 possible answers are provided. Very, very important for us to read the question and understand. It says elements. We need to understand what an element is. So it's very important to also underline the keywords, in a question, so that it even helps us in terms of recalling some of the key concepts that are related to that. So we know that an element is made up of atoms of the same kind. These are substances made up substances. So an elements are substances made of atoms of the same kind, made up of atoms of the same kind, okay? Of the same kind. Hence, we talk about the periodic table of elements, right? So they are arranged in the periodic table. If I can draw your attention a little bit to the periodic table. This is what we have as far as the periodic table. So as you can see, there is the periodic table. Now the symbols have been used, right? So this is element number 1, number 2, 3. It goes across in rows as well as columns. So these vertical rows is what we call them groups, right? Right. And then the horizontal rows, we call them the periods. Right. So if we talk about the periodic table, we're basically talking about the arrangement of elements in this fashion. So it goes across in terms of the atomic number. So the number of protons, which determines the position of the element in the periodic table, is basically what it is, right? So having seen how the periodic table is arranged, it has nothing to do with the mass, because the mass is number of protons plus neutrons, or this is sometimes what we call the nucleon number, okay? Nucleon number, right? So the periodic table is not arranged in that respect. It is arranged in terms of atomic number, which is proton number, okay? Proton number. So atomic number is proton number. And basically it says to us, we need to have an idea of what each one of those mass number and atomic mass is one and the same thing, right? These are alternate. These two terms may be used interchangeably to refer to the same thing. So in this case, atomic volume, atomic size, it has nothing to do with the arrangement in the periodic table. However, there are what is called the trends as well as the periodicity, which I'll discuss as we go further. So in this case, it's arranged in terms of atomic number. Our answer is B. So 2 of the answers in this case are distractors. So ours is to identify the 2 most correct answers, or the 2 most probably correct, but one of them is actually the correct answer. So in terms of eliminating, again, it could work to our advantage. Hence, I would want to emphasize that no learner must leave a multiple choice problem unanswered for whatever reason. So the idea is to read the question and understand it. Now I'm going to give you the next 2 minutes to look at the next questions. So I'll be flipping. I'll also depending on the complexity of the problem. So I'll give you 2 minutes to just go through each one of those, and then after that we'll try and consolidate. Right. Starting from now, let's look at this question one after the other. Right. Okay. So this is the first question. 2 minutes starting from now. Let's go for it, guys. Welcome back, guys. Hopefully you've made your attempt on the few multiple choice questions, trying to apply some of the techniques that we have discussed previously in the example. Now let's look at one question at a time and see how best we can right. The first question says, which element increases its electrical conductivity? So electrical conductivity, we want to think of it as a physical property of material, right? Physical property of material, okay, of a material. So in this case, which materials are we exactly talking about? We're talking about these elements that we refer to as metalloids. Metalloids are sometimes we refer to them as semi-metals. So this is a physical property of metalloids, right? Metalloids or semi-metals, that's what they are, right? Semi-metals. So in this case, it will be very important to understand the layout of our periodic table. If I can draw attention to the periodic table once more. All right. So from the periodic table, this is what we're saying. So our metalloids are these elements, right? Remember the steps, okay? It goes on like that. So your silicon, your astatine, your titanium, and your boron are these examples of these metals that are called metalloids. So to the left of them, we've got metals, okay, right? Then to the right of these semi-metals, we've got non-metals, right? That is in terms of classification of elements in the periodic table based on their properties. So obviously the only metalloid or the semi-metal that we have in this case is silicon. So it has to do with the periodic table, right, and the arrangement of elements in that very important tool, right? So if we look at the next question, it says here, the following is an example of a decomposition reaction. There are two types of reactions that we've discussed during the course of the term. We spoke about decomposition or synthesis reaction when we spoke about the chemical change. So typically in any chemical change, we must understand in terms of classification, we've got synthesis, right, which has to do with turning simple substances and making complex synthesis to produce, like your photosynthesis, as you could come to think of it in your life sciences, right? And then also we have got the decomposition, right? So with the decomposition, what is actually happening here? We are saying that a complex substance is broken down into simpler one. So this one has to do with the synthesis, right? In this case, we are making carbon dioxide from, this fuel. We want to think of this as a fuel, which is a hydrocarbon, something that will deal with at a later stage. So this is synthesis, okay? Because it has to do with combining of substances to form simple substances, right? And then this one, the one of lead 4 oxide, breaking down into lead oxide, and it's an example because I've said synthesis, which means decomposition, which has to do with breaking down. So for that reason, this is a typical decomposition chemical change or chemical reaction, right? So it means this other one is synthesis, so we need to classify first so that we can be in a position to get the correct one. This is also synthesis from simple to more complex. So this is another synthesis. Very, very important to remember that, right? That said, let's look at the question. So in other words, this B becomes the most correct answer, right? Okay, now which of the following is a physical change? Then we need to remind ourselves what exactly a physical change is all about. In a physical change, the mass of the substances remain the same. It can have a color change, shape, or even state or phase. So physical change can be a change of phase, right? It could be a phase change. It could be a color change, It could also be a change of shape of a material. So we would refer to this as a physical change. In other words, a physical change can happen in one of the three ways, right? When sugar caramelizes, this is a typical reaction. Iron and sulfur are melted. They form iron sulfide. This is a compound. So this is a chemical change because new bonds and new substances are formed. But if you look at the one of magnesium plus oxygen, which is D, it gives us magnesium oxide. In this case, it's a white solid substance. This is a gas. We can think of this as the burning. So this is a chemical change. So in other words, the one that suggests that it's a physical change is called melting, which has to do with a phase change, right? It has to do with a phase change. So this is a typical example of a physical change, right? Okay, that said, then it says here sodium carbonate reacts with hydrochloric acid. Okay, chemical formula, very, very important. So when we talk about sodium carbonate, we are talking about Na2, okay, CO3, which is a salt, okay, a solid, right? It reacts with an acid. Okay, this is from grade 9, HCl, which is an aqueous solution. It gives us sodium chloride, which is the salt, right? Plus water, okay, plus carbon dioxide gas, right? That's what we know, right? So this is a typical chemical change or reaction that takes place. So we know that if a metal carbonate reacts with metal carbonate, reacts with an acid, metal carbonate plus an acid, what do we get? We get a salt, okay, water, okay, as well as plus carbon dioxide gas, okay, plus carbon dioxide. So the gas that is formed in this displacement reaction is called carbon dioxide, right? That's our CO2. So hence it leaves us with that as our solution, which is option C, right? Now, the last question that I want us to discuss, just to wrap up the multiple choice, which one of the following are properties of metals, okay? So these are physical properties that we're talking about in this case. There are many of them, if we can mention quite a lot of them, I think electrical conductivity, thermal conductivity, malleability, ductility, boiling point, melting point. So it also goes back to the periodic table to be in a position to identify those materials that we use in our everyday lives that we want to think of as non-metals. We remember that non-metals are, in this case, if we could go back again quickly to the periodic table. Right, it says here, these are the materials which are non-metals in this case, okay? All these ones are non-metals, because they are on the other side of the semi-metals, okay? So that's in terms of classification. So non-metals are definitely bad conductors of electricity. They are dull, and however, they are not malleable, because if they are not malleable, it means they are brittle. So that one takes it out from the combination. They are brittle, that is true. Shiny, no, because they are dull. Okay, so we check that. This takes it out. Okay, insulators, yes, insulators are bad conductors. Now that's what we know. What an insulator, dull, which is the opposite of shiny. They can be solids, liquids, or gases at room temperature. Right. Okay, let's check. They say here bad thermal conductors. Okay, bad thermal conductors. In other words, they are insulators. They are also brittle, and they say here they are never solids. Most of them are gaseous substances, as we have seen. So, which means indeed D becomes the correct answer. I think in this case it says that they can be in any one of these three at room temperatures, which is not true. Most of them actually are gases. So, and if you check from the periodic table, most of them are never solid at room temperature, right? So I think the catch there was at room temperature, right? Now let's wrap up that. That will be the last question in terms of the multiple choice. We have emphasized on the key technique. Read the question carefully, underline the keywords just to emphasize and just to try to remember. And then after that, you could consider your possible options based on the knowledge that is relevant to that question, right? That said, we shall take a short break, and then after the short break, we shall come and look at section B, which is your typical structured or long type of questions. Right, see you after the break, guys. Welcome back, people, from our short break. Now we want to focus on the structured questions. However, the technique also remains the same. However, it's important that whenever you start with the multiple choice, you should manage your time very well so that you have got enough time to respond to the rest of the question. Some learners would prefer to start with the long question, but it's advisable, again, that you leave ample time so that you can complete the multiple choice within a reasonable time, right? And then we have a typical practice question in this case, which is based on the periodic table as well. So the periodic table becomes pretty much a very valuable tool. Now, I'm going to give you 3 minutes to attempt the 5 sub-questions on the first long questions. Then we'll do the feedback and talk to even related concepts that not only confine us to these questions. So your 3 minutes starts from now. Let's go for it, guys. Welcome back, guys. After the attempt of your first structured question, which is based on the periodic table, it certainly says to us that we shall indeed make reference to the periodic table one time or the other just to keep everything in check, right? The question reads, chlorine is a yellow-green poisonous gas. So chlorine, it exists as a gas, and chlorine, we know it's a non-metal in terms of classification. So chlorine is a non-metal, and we know that chlorine is also diatomic. So it means it consists of the two atoms of the same kind chemically bonded together. So this is a molecule of an element because these are atoms of the same kind. Right, let's look at the first question. Right, it says we want to draw the Aufbau. The Aufbau diagram actually shows the electron configuration of an element. All right, electron configuration or the layout of electrons configuration, okay, of an element. In this case, we shall use the Pauli exclusion principle, okay, Pauli principle, principle, as well as the Hans rule. These are very key in terms of coming up with the Aufbau diagram. So we know that these electrons are half spins in opposite directions because they carry the same charge. So we shall first start by placing one in each suborbital, and then after that we do the pairing. This with respect to these very two important rules. So in the S can be occupied a maximum of 2. So we know that this chlorine, if we can draw attention quickly to the periodic table, just to check the atomic number, which will also give us the number of electrons. So in this case, this is our chlorine. Chlorine is atom number 17 in the periodic table. It is in period 3 in group 7. Group 7, remember we call them the halogens. So that's 1, 2, 3, 4. Okay, then we go to the Hans rule, and then says 1, 2, 3. Okay, and then we start the pairing. Okay, now so already we have 10. Okay, 11, 12. Okay, so now we have got 6, 7, 8, 9, 10, 11, 12, 13. Okay, 14, 15. Okay, 16. Okay, 17. Right, so this is the highest energy level. This is the highest energy level, right? Highest energy level, or the highest orbital. Okay, energy level or the highest orbital. Now in this case, it has got the S and the P suborbitals. Right, now what we're saying here in this case, these are the 7 which occur in the highest energy level. So these what we call the valence electrons, right? This is the number of valence electrons. This is the valence. These are the valence electrons, or these electrons that occupy the highest energy level. So there are 7 of them. Okay, that's why chlorine is in group 7 or group 17 if you want to choose it. Okay, so it means it has got 7 valence electrons. Now those are the number of valence electrons. So there are 7 electrons. Okay, at the highest energy level, right? So this also gives us the group in which it occurs, which means it's group 7. However, we also need to understand that this 3 tells us that it occurs in period 3 in group 7. So right, in other words, it's group 7. Okay, period 3, because there are 3 energy levels. So the number of energy levels gives us an indication of the period, right? The number of energy level gives us an indication of the period, and then the group in which it occurs, it gives us an indication of the valence of the electrons, or the number of electrons that are at the highest energy level. So it says, what type of bonds do you find in chlorine gas? We know that chlorine is a molecule of an element. Hence, we said its formula is Cl2 gas. So the type of bonds in this case are the covalent bonds, right? Covalent bonds. Remember that the word core means to share, right? Co means sharing, okay? And then valent, in this case, we meaning the electrons at the highest energy level, right? These are sharing of the electrons at the highest energy level, right? So covalent bonding is very much evident in this chlorine. So if we talk about the two types of bonding, we've got the ionic, which has to do with the transfer, as well as the covalent bond, which has to do with the sharing of electrons at the highest energy level. However, the big question as to why do the atoms of element bond? They want to bond so that they can have a stable electron configuration that resembles that of elements in group 8. In this case, these are your noble gases and your halogens, which are generally unreactive, right? So the next question says we must draw the Lewis diagram, right? So let's say we've got these two chlorine atoms, that's our Cl. Now this one has got 1, okay, 2, 3, 4, 5, 6, 7. These are the electrons at the highest energy level. It doesn't mean there's only 7. So when we draw the Lewis diagram, we only show the valence electrons, very, very key, because they're actually the ones that are involved in this type of bonding. We have the same atom, okay? Now we have got, it has also have a valency of 7, right? So for them to be stable, each one of them needs to have 1. So none of them is going to give the other. In this case, they are going to share this pair of electrons, so that all of them now are stable with a stable electron configuration, similar to that of which element in this case? Okay, if we can check in the periodic table, chlorine wants to be like argon. So if they gain 1 from 17, they now have 18. So they behave like these noble gases, which are halogens, which are group 8 or group 18, right? Now, so that's basically what it is. So if we can also present it, that's why we say it's Cl2, the formula, as well as we can go do the Cooper notation. Some of you understand that we do this a pair of shared electrons. Then that's what basically it is. Okay, what is the name of the type of structure that is formed? This is a covalent molecular structure. This is covalent, right? Molecular structure. So it's covalent molecular because it has to do with the sharing of electrons. Quite a lot of concepts come into play in this part of the topic. So the periodic table, we cannot emphasize the importance of the periodic table. So one time or the other, we need to refer to our periodic table because it's a valuable tool, and we need to understand that even in an exam, it shall be provided. So we need to familiarize ourselves with the periodic table, right? Okay, let's move on. Right, now it goes on the same question, but this one we'll do it together, still on the same chlorine, or on the same substance, which is chlorine, a poisonous gas. We said its formula is Cl2, which is a diatomic element. Now, it also forms compounds with sodium as well as hydrogen. This is a metal, we remember. Now, use the Lewis diagram. Again, the Lewis diagram is a very often used structure to show the type of chemical bonds, right, that we'd expect between sodium and chlorine. So when we talk about this chemical bonding, so we shall have the two, which is the sodium, the metal, okay? Sodium, the metal, is a valence of 1 because it is in group 1, right? So at the highest energy level, it has got 1 electron. And then we've got the chlorine, right, which has got what? 7, okay? So if they've got 7, it means it is in group 7. It has 7 valence electrons. Now, if you check your periodic table clearly, you'd realize that there we have our sodium. Sodium has 11 electrons in total. So if it is 1 at the highest energy level, this is an indication of the number of valence electrons in this case, right? So if it loses 1, it will have a structure similar to that of neon. So to achieve stability, sodium would rather lose an electron to chlorine, which is in group 17, right? Chlorine is in group 17. There is our chlorine. So that when chlorine gains, it has 18 electrons or 8 electrons at the highest energy level, so that it has a structure similar to that of argon, right? So that's basically happens? So this leaves us with the fact that this must, the sodium, which is a metal, must lose to form a cation, and then chlorine must gain an electron to form an anion. So what is going to happen is that if this one is transferred there, so what are we going to have in this case? We will have this extra electron there. Now, what do we have, guys, in this case? Very important for us to note that that is the electron. So once we have that, now we have this chlorine being negative and that sodium being positive. Then we get our NaCl, right, which is our salt there. So this is typically ionic bonding. We have shown the ionic bonding using the Lewis diagrams, right? Now let's look at the chlorine versus the hydrogen, right? So if you look at hydrogen, hydrogen has a valency of 1, meaning it has got 1 electron at the highest energy level, right? But in this case, I want us to be very careful as far as hydrogen and chlorine. Typically, what is going to happen here? The chlorine has how many valence electrons? 7, right? Okay, hydrogen, to look like helium, it needs to have an extra electron. Also, chlorine also needs another electron. So what is going to happen in this case? Basically, what are we saying? We are saying that these two will share that single pair of electrons which will belong to it. Now, you look at hydrogen, it has a structure similar to that of helium, whereas chlorine is a structure similar to that of argon. So in this case, we get our HCl. So this is typically covalent bonding. Okay, right. Very, very key to distinguish between those two types. Right. That said, I think it brings us to yet another very interesting aspect of it. For us to be in a position to identify the type of bonding that actually takes place between two elements or two atoms, we have to check the valency and also check if there has to be transfer or there has to be sharing, so that to achieve a stable electron structure that resembles that of group 8 elements. That said, this brings us to the end of our first segment. We shall take a short breather and then we shall continue with these structures questions, maybe in a different topic altogether, just to get ourselves ready for the June exam. Let's take a break for now. See you after the short interval. Welcome back after a short break to our last segment of today's revision, paper 2, chemistry grade 10, physical sciences. Now let's look at a question that has to do with an experiment or an investigation, which is pretty much a very important aspect in science. Remember, in science we ask questions, in terms of the investigative questions. We also make educated guesses or predictions, and then we put those into test, and then we collect the results and use our findings to draw logical conclusions. So one of the experiments that is very common, which we did in the first term, was the heating and cooling curve of water. Right, let's look at this one. It says here, timber heated substance X. We don't know the identity of substance X at a constant rate, meaning that whatever heat source was used, it supplied the same amount of heat over a period of time using a lab Bunsen burner. So the Bunsen burner becomes a piece of apparatus that is used. He then drew a graph of temperature versus time for the data he had collected. So keeping track of data is very, very important in science. So this is the graph that represents, so this is temperature versus time, right? So it's very important here. We want to understand what happens to temperature as we continue heating a substance, as we investigate its heating curve. So temperature versus time becomes the title of the graph. Very, very important. We need to include that. So we have got different times. So this is time. Time in this case becomes our independent variable. So we take the temperature readings at equal time intervals. So this becomes independent, and the temperature, which is the response variable, sometimes we would call it the dependent variable. Okay. So we want to classify and identify the two. So in this case, every 2 seconds, every 2 minutes, because time is in minutes, we take the temperature reading and then we plotted that graph of temperature versus time. Right, let's go on and check. It says here, at which points, we just have to use, in this case, we are interpreting the graph. Interpreting the graph, okay, which is a skill very, very critical in science, right? At which point or between which points? So this could be an interval, okay? This could be an interval between 2 points. It's an interval, and then a point is at a specific time. In this case, we're talking about A until, if you can check, it says A until F. From A to F, okay, we shall be constantly referring to the graph, okay, just to make sense of what, at which temperature, at which points, or between which points, which is an interval A to F, okay, does the substance X have no definite shape? This is a characteristic of a particular state of matter. We have 3 states of matter, which is solid, all right, liquid, okay, as well as gas, right? So if we talk about those 3 states of matter, it's very important to understand the characteristics or the properties of each. You know that the only one that has got a definite shape in this case is a solid, right? So liquids and gases do not have a definite shape, in the sense that if you think of a liquid, we say the particles of a liquid tend to slide past each other, and that gives rise to the fact that it takes the shape of the container. Very, very important. But it has some form of kinetic energy which is greater than that of the solids. And then when you look at the gas, particles of gas, any gaseous substance tend to move very, very fast, because there are very weak forces that keep them together. So they occupy a huge space in a short space of time because of the kinetic energy that they possess. So the gas fills all the spaces that are available. For that reason, we can say that the gas does not have a definite shape. So let's go to the graph and look at the points in a graph which represent segments which the substance does not have a definite shape, right? Okay, so if it does not have a definite shape, okay, let's check. Have no, okay, right, no definite shape. So if we go back, we can check between which points do we have liquids and gases. So between A, okay, is still a solid. Between B and C, is changing from solid to gas. So this is a phase change between BC, right? This is phase change, right? Phase change, right? In this case, this phase change is a physical process which you call melting. And then between D and E, it is changing into a gas. So for that reason, we can say between A and D, then we have this substance having no definite, in between A and B, it's a solid, okay? So between C, it's in this case, it's already melted, it's a liquid. And so between C and F, okay, that's when we have a liquid as well as a gas, liquid form as well as a gaseous form, okay? Because between B and C, there's a phase change, which is, in this case, this phase change is what? Melting. Right? Okay, where the temperature remains constant. So when it has no definite shape, it's between point C as well as F, right? So between C and F, it does not have a definite shape. So we also want to look at where the substance does have a fixed shape. In this case, it will be a solid, right? So we have already mentioned that between A and B, it is in solid form. If you can go back to the graph, so between A and B, it is in solid form. That's the interval. Or between 0 and 6 minutes, it is still in solid form, because it begins to melt between B and C, right? So in this case, we are saying that between A and B, it is in solid form. It has a fixed shape. Okay. Now, does it have no change in kinetic energy? No change in kinetic energy takes place when there is a phase change, whereby the kinetic energy phase change. During phase change, what do we know? EK, which is kinetic energy, remains constant. right? It remains constant. So let's go to the graph and check where there is no change in kinetic energy, which is particularly the temperature, right? So if we can go to the graph, you'd agree that during this phase change BC, okay, and in this case DE, there is phase change because temperature is 140 between 18 and 26, okay, as well as between 6 minutes and 12 minutes. So we have got BC and DE, right? So BC and DE, BC and DE, temperature remains constant because there is a phase change, which is a very important part of this. So the melting is substance X at its melting point. At the melting point, we know that it changes from solid to liquid in this case. So at which time did that occur? It occurred between B and C, okay? Because that's where there is the first case where we have temperature remaining constant. Now, the substance changed to a gas. So if the substance is changing to a gas, we are looking at this particular aspect between D and E. There's a phase change in this case, right? So there's phase change between D and E. So there's phase change because temperature remains constant between that. So this is what we call evaporating, or it is a disboiling point. So that temperature is 140 degrees. So we call that the boiling point, right? And then if we can go down the temperature of 60 degrees, we call it the melting point. So this is a temperature at which the actual phase change takes place, right? Now that said, I also want us to look at the next question. The substance, both solid phase and liquid phase. So that happens during that temperature, where the temperature remains constant. So that one was between B and C, because we know that during phase change, this is the point that we need to take home, that during phase change, what happens during phase change? Important to know that temperature remains constant, okay? Because as we continue heating, the average kinetic energy of particles increases, but during phase change, temperature remains constant. This is a very, very key concept in this experiment, right? Okay, so is this substance a liquid phase? Is the substance in liquid phase? So we know it's only in liquid phase before it changes into a gas. So if we go to our graph, we would understand that between C and D, it is in liquid phase because it only changes from liquid to a phase to gas between D and E. Very, very important, right? Between D and E. So these are the 2 points where phase changes take place. But between C and D, it is in liquid form, right? In liquid form. Okay. So that's what we must know at this point, right? Now, that said, we need to go back to our questions, okay? We've done that. So do the molecules have the highest average kinetic energy? Highest average kinetic energy. This is average kinetic energy is an indication of the temperature of a substance, okay? The temperature of a substance, okay? So the average kinetic energy, according to what we call the kinetic molecular theory, the average kinetic energy is the temperature of a substance. So we know that solids vibrate. Particles of a solid, they vibrate within fixed positions, right? And then liquids, they tend to slide past one another, right? They slide, okay? Okay, and then as far as gases are concerned, what exactly happens? Particles of a gas tend to move very fast and occupy most spaces within the shortest possible time. So in terms of kinetic energy, we want to think of it as the energy that particles of a substance have as far as movement or motion. So in this case, in a gas, that's where you experience the highest part. So we go to the graph and identify those aspects where the average kinetic energy of the molecules is greatest. Right. That was what was important as well. mile, right? Okay, that said, I think if you look at the boiling point, we've already spoke about it. We say it is 140 degrees where the temperature remains constant. And then the melting point, I think we got 60 degrees Celsius, right? So this is the temperature at which phase changes take place. How long? This is the time, okay? How long speaks to the time. Does it take X to change from a solid to liquid? So this, what type of phase change is this? This is melting. Okay, so we check how long did the temperature remain constant, right? So if you check during melting, this is the melting happened between the 6th and the 12th minute. So delta T in this case is equals to 12 minus 6. So in other words, it took 6 minutes, right? The time interval there, very, very important. We can also determine the one for boiling, where temperature remained constant. It took place between 18 and this, okay, we can say 26, fine. So delta T for boiling, it took place between 26 and 18. In this case, what do we get? 26, 6 minus 8 is 8. Okay, it took 8 minutes. It was a bit longer, right? It took 8 minutes. So the time for boiling is 18 minutes, right? Okay, so that said, I think we can now, we are in a position to ask how long does it take for the solid to change. I think we've also attempted that. Okay, right. That said, I think we are in a position to say, as far as the graph of temperature versus time, we will use a thermometer, for example, to measure the temperature. However, we need to have a stopwatch. One must be a timekeeper. In that way, we can be in a position to make sure that the time intervals which we measure the temperature is constant. Hence, the interval becomes control variable. However, the time at which we do the entire experiment until the substance is in a gaseous phase and the temperature is no longer increasing, then we can then stop it there and also get our data to use to plot the graph. Remember, a graph must have the heading, the labels must be correct. You know that the independent variable is always on the horizontal axis, whereas the dependent or the response variable is always on the vertical axis. Now, there are quite a lot of concepts that we've discussed today, but for the sake of the exam, it's important to constantly remind ourselves of what is key in each and every aspect, and also identify that, oh, this question is on the experiment because it has to do with the scientific inquiry, which is a very, very integral part of science, because for us to draw conclusions, we need to be in a position also to collect data and prove our hypothesis, whether correct or incorrect, so that we can derive our scientific facts. Right. That said, guys, this brings us to the end of yet another exciting session, the last for this term, hoping that you do well in your June examinations. Until we see each other, from myself, Themba Ncube, is goodbye and cheers for now.